All right, let's try to simplify this expression that has negative exponents. What we have is 2x squared y z to the negative 2 divided by 3x to the negative 2 y cubed z to the fifth, all quantity squared. Now, when you see this, I see a couple things that catch my eye. First of all, these negative exponents need to be adjusted at some point, which you recall, if you have a negative exponent in the numerator, you'll move that term to the denominator with a positive exponent, or vice versa. You can move this negative exponent in the denominator up to the numerator and make it a positive exponent. But then I'll also notice we have this overarching square term where everything is squared that needs to be distributed at some point as well. So both of these are major things that I see we need to take a look at. Now we have two options and they're both fine. It's your preference. We can fix the negative exponents either early or late, meaning we can take care of the negative exponents right now and go ahead and put them where they're going to be and simplify the inside of the parentheses, and then when we're done we'll just square everything. That works. Or if you want to go ahead and get rid of these parentheses, you can go ahead and square all the terms on the inside first, and you'll have negative exponents, but that's okay. You can fix the negative exponents later after you've squared everything. They're both okay with me. I don't mind either way. We can do it either way. So it really is up to you, and whichever way makes sense to you. I think what I will do is let me go ahead and simplify the inside first. If you want to do it the other way, no problem at all. So I'm going to simplify the inside first. So I'm going to take care of this x to the negative 2 and the z to the negative 2 first. So let's see here. We'll take both of those guys and move their locations. And so we'll have 2x to the second, and then this x to the negative 2 is going to come up to the numerator and become x to the positive 2. And then we still have a y. And this z to the negative 2 will be gone because he's going to go to the denominator. And then in the denominator, we'll have 3. This guy has been moved already up to the numerator. Y to the third, z to the fifth, and then z to the positive 2 because of this z to the negative 2 in the numerator. And then we have to square everything. Okay, let me come back up here. Let me write one extra line here. I probably could have skipped this step if we had tried a little harder. Let's go ahead and combine these x's and z's. We'll have 2x to the fourth y, because x squared times x squared, you add the exponents, divided by 3y to the third, z to the seventh. Because we have z to the fifth times z to the second, you add the exponents, get z to the seventh, and then all of that squared. Okay, so I handled the negative exponents earlier, and now notice what's inside my parentheses has no negative exponents. So I can now handle this squared right here, and let's just go ahead and finish it in one step. I have to square everything. 2 to the second is 4. X to the fourth to the second is x to the eighth. If you recall that property that says a power to a power, you multiply the powers. Y to the second, and hopefully you see what I'm doing here. I'm squaring the 2, the x to the fourth, and the y. Then I have to do the same thing to the denominator. 3 to the second is 9. Y to the third to the second is y to the sixth. And z to the seventh to the second is z to the 14th. So both routes will lead you to the correct answer. And so anyways, I think this is our solution for this problem.